Okay, welcome back for part 4 of chapter 6, and hopefully the last one. Keystone species. A keystone species is an organism that affects the ecosystem to a point where they actually have an impact on many different species in the area. They are often referred to as an environmental engineer, if you will, that they are doing something that actually provides for other animals and makes potentially more niches within the environment and therefore affects more species. The classic example is the beaver. He builds the dam, it creates a pond that impacts a lot of different species in the area. And so he is an environmental engineer. Other ones, elephants, they knock down a lot of trees. That actually helps to keep the savanna open and have less trees on it. Gopher tortoises here in Florida, their burrows, over 300 other species use their burrows, both when they're in them and after they've abandoned them. So they are also ones. So there's different types of keystone species. Yeah, it's nice to know these, but it's probably not a huge deal. You can have keystone predators, ones that outcompete other animals, and then of course the ecosystem engineers, which are most of them and stuff like that. But lots of critters are them. Here you go. The salmon is a keystone species because it actually introduces a whole lot of nutrients into high mountain streams when they go up to lay their eggs, and then they die. And not only do the bears eat them, but the carcasses actually that are in the stream and on the side of the stream will provide lots of nutrients. And I keep saying so I apologize for that. Okay, moving on to basically one of the last things in this things, and that's ecological succession. Succession is what occurs in a location over time. So it's kind of a step-by-step what happens. There's two types of succession. There's primary succession and secondary succession. You need to know them, the difference between them, but it's actually pretty easy. In primary succession, you start with bare rock. There is no soil. So you have bare rock. The pioneer species that come in are your lichens and mosses. They actually produce acids that will help start to break down those rocks, and those rocks then create soil. The soil, once it creates, then you start getting weeds. Weeds will help make more and more and more soil, and then you get more weeds and grasses, and then pretty soon shrubs and trees, and pretty soon you're back to the original biome, or the biome in that area. This can take hundreds and hundreds of years, and it can be interrupted. But, most important thing, primary succession occurs in locations where there is no soil. So a brand new volcanic island, a glacier valley, and the glacier melts and there's just bare rock. It has to be bare rock. If there's any soil, it is secondary succession. So in primary succession, you have bare rock. You have your lichens, your mosses, your algae. They come in and they start breaking things down. Then they die, and then they provide nutrients and so on and so forth as you go through the succession. In secondary succession, soil is present. Okay, that's seriously the only difference is no soil, soil. Usually secondary succession occurs after a natural disaster, a fire, a hurricane. Something comes through and devastates the area, floods it, knocks down the trees, whatever, burns it all up. And then in come the weeds, and then the bushes, and the grasses, and then the trees, and eventually you get back to the biome you originally had. In this case, your pioneer species are the grasses and the weeds, because you don't need the lichens and mosses. You already have soil. So they'll come in. And this is usually quite a bit shorter process because making soil is a very lengthy process. So this one's a little shorter. So if we abandoned the campus and let nature have the campus back, that's secondary succession. If you are, planting fields and you're doing agriculture and you abandon it and let nature take over, that's secondary succession. So this usually happens after a natural disaster. or man-made disaster. So this is an idea of primary succession. You start out with your bare rock and stuff. And that picture that they're showing, it's not a progression through distance, it's a progression through time. So each of those little squares is replaced by the previous one. So that's all the same area, kind of over time. I'll try to show you a video if I can in class. And again, for a succession, again, it can take hundreds of years. And it can also be disrupted partway through. It can get through it, and then a fire occurs or something. And then you're taken back to the beginning. What's kind of interesting is productivity is very low in the beginning, and so is biodiversity, because you just have a few grasses and weeds. And then at the end, your productivity is really high, but your biodiversity, again, is really low, because the animals at the climax community have outcompeted a lot of species. So kind of in the middle is when you have a lot of biodiversity, because you have both the early species and the later species kind of all mixed together. Oh, let's see if I have this video. Could I possibly have it there? Oh, come on, play. Preview. Let's see if it'll play. Well, that's the Bozeman video in succession, so you can go look at that. Don't know why it will play. We're trying. Nope. Oops. That's not what I meant to do. Okay. That's the succession video for Bozeman, so it should be up there. If it's not up there, I'll put it up shortly. Okay, so a little bit of interesting information. Not really that you need to know this. This is more actually IB-ish. But early succession, you have a lot of low gross primary productivity, but a lot of high net primary productivity, blah, blah, blah. Your food webs are very simple. In the end, your food webs are very complex. You have a lot more niches later in your succession, because there's just a lot of more habitats, and you're much more likely to having a K strategist, versus in the beginning it's a very simple structure and you're much more likely to have an R strategist present. So just something interesting. Aquatic succession. Aquatic succession is actually just the filling in of a pond. So you have a little lake or a pond, and literally over time it will accumulate sediment until pretty much it gets filled in, and then it will become whatever biome is around it, kind of thing. And that's aquatic succession. Primary and secondary succession tend to increase biodiversity. You increase until you kind of get to the end, and then it decreases a little bit because a lot of other species are outcompeted. It increases species richness and the interactions among species, so you get a more complex food web and that kind of thing. Primary and secondary succession can be interrupted by fires, hurricanes, clear-cutting the forest, plowing, whatever, invasive species. So it can be kind of set back at different times and all, which is not necessarily a bad thing. Okay, one thing your book does not talk about is zonation. And zonation is changes in the environment over a distance. This is a spatial pattern, where succession is a temporal pattern. It's a time pattern. This is a space. So if you go to the rocky shore and you go deeper and deeper and deeper, the critters that are there kind of change as you move along the thing. And same kind of thing as if you go to the edge of anything, basically. And as you progress, you will often see a different change. You'll see kind of a banding pattern, if you will. And this is zonation. I think you just need to be aware of it and know what it is. Know that your organism distribution is going to change as you move through areas. Here's one for a pond and stuff. Just basically as you move along, you're going to get this zonation occurring. The most classic example is the rocky shore pictured here. There are tide pools and stuff as you go into the beach. And you can also see this like on pilings for piers and stuff like that. As you go down into depth, you'll see different bands of organisms based on the different abiotic factors. occurring, and that's just referred to as zonation. Okay. Factors that determine species richness. This is just kind of a side thing. Latitude and time. Latitude. As you go north and south from the equator, biodiversity or species richness decreases because a lot of animals cannot deal with the more severe weather. So you actually decrease in species richness, or the number of species. You also get the same thing happening in time. Over time in a habitat, usually the number of species increases the longer the habitat's there. So throughout succession, the longer it's taking, the more likely you are to have more species. And that's just something to note in the back of your head. Okay. Theory of island biogeography. I've talked about this a little bit in the past when we talked about biodiversity. This actually is at the end of this chapter, though. The idea is that habitats work as islands. The bigger the island, the better. The more niches, the more species you'll have compared to a small island. Also, the closer your species is, or your island is, to the source of your species, your mainland, if you will, that's better too, because they can just, hop right on over. If you're very, very long ways away, that's a problem. So, the idea is larger habitats are easier to find. They have more space for more species. They have a wider range of environmental conditions, which would make more niches, so you can have more species. Little islands would not have that. So if you graph the theory of island biogeography, and you kind of did this in a way if you think about it with your habitat loss lab, if we kept going bigger and bigger, you would actually kind of plateau at some point. But the bigger the island, the more species it has, more niches, more environments, more habitats. And again, the closer it is to the mainland for other animals to join them, the better. So a large island close to the mainland is your best. A small island far, far away is your worst. The others are kind of in between. You'd have to look at them specifically. The problem is that we actually are doing this with our reserves, our national parks and stuff. They end up being islands of preservation, which are good. It's better than nothing, but they function as islands. They're surrounded by humans. They're surrounded by everything. And of course, my dog's playing with this squeaky toy, if you can hear that. They're surrounded by all kinds of human development, so they function as islands. So if we're going to let them function as islands, and that's all we're going to do, we need to make sure they're close together and they're as big as possible. So that's something we need to be concerned about. Okay, so that is the end of chapter 6. If you have any questions about anything, please let me know in class, and thank you for listening. Bye.